You're listening to DTFHN for February 2026. I'm your open source or die host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people who mass email strangers somehow coexist with people who audit bash scripts for fun. Today's a day where promises expire and architecture outlives the architects. Strap in. One file, one bash script. That's the whole thing. Terminal phone is a walkie-talkie that runs in your terminal. You talk, it records, compresses, encrypts, and ships your voice through Tor to whoever's on the other end. No server, no account, no phone number. Your identity is a .onion address, which means your identity is also your encryption key, which means your identity is also your network address. One artifact doing three jobs. Run this forward. Every communication tool you use right now requires you to trust someone in the middle. Signal requires Signal's servers. WhatsApp requires Meta's servers. Even Matrix requires whoever's running your home server. Terminal phone requires Tor, which is a network, not a service. There's no company to subpoena. There's no database to breach. There's no terms of service to update at 2 in the morning on a Friday before a holiday weekend. Now, the comment section has someone asking why the script offers 21 cipher options when one good one should suffice. And honestly, fair. But here's the context that makes this interesting rather than alarming. The whole thing is a bash script. You can read it. Every cipher choice, every network decision, every piece of logic is right there in a file you can open in Nano. The 21 ciphers aren't a liability when the user can verify exactly what each one does. Opacity is the threat model, not optionality. The architectural choice that matters is using Tor's v3 onion services as the entire infrastructure layer. No stun servers, no turn servers, no NAT hole punching, no WebRTC negotiation dance. You start the script, Tor handles the routing, and the onion address handles the cryptographic identity. One commenter called it clean. It's cleaner than that. It's what happens when you build on a protocol instead of a platform. Someone in the comments mentioned Arty, which is Tor's client rewritten in Rust as an embeddable library. When that ships with full onion service support, this pattern. Get in service as application backend stops being a clever hack and becomes a building block. Imagine every peer-to-peer tool shipping with Tor, baked in, not as a privacy add-on, but as the transport layer. No infrastructure costs, no scaling problems, no company holding the keys. The whole project is a single file you can audit in an afternoon. And that's not a limitation, that's the point. The tools exist. The network exists. Someone sat down and wired them together in Bash, and now anyone with a terminal has access to communication that no third party can intercept, shut down, or monetize. That's bootstrapism. Not a manifesto, a shell script. Moving on. In 1995, Microsoft shipped Windows with a networking stack that trusted every packet on the local network. NetBIOS, shared folders wide open, no authentication required. The assumption was simple. If you're on the network, you belong here. That assumption held for exactly as long as nobody plugged a Windows machine into the public internet. Then it became the single largest attack surface in computing history. Not because the software was broken, because the environment changed and the assumptions didn't. Google just did the same thing with API keys, and the architecture of the failure is almost poetic in its precision. Here's the biology. In immunology, there's a concept called immune privilege. Certain tissues, the eyes, the brain, the testes, exist behind barriers that the immune system doesn't patrol. They're not defended because they were never supposed to be exposed. The body doesn't distinguish between safe and undefended, because in a healthy system, the barrier does that work. Breach the barrier, and the immune system has no idea what to do. It either ignores the threat entirely or destroys the tissue trying to respond. Google API keys were immune-privileged tissue. For over a decade, the official documentation, the security checklists, the Firebase guides, all said the same thing. These keys are not secrets. Embed them in client-side JavaScript. Ship them in your HTML. They're billing identifiers, not credentials. Developers followed this guidance correctly. They put keys in public code because Google told them to. Then someone enabled the Gemini API on the same project, and every one of those public billing tokens silently became an authentication credential for sensitive AI endpoints. No notification, no confirmation dialog, no email. The barrier dissolved and the immune system never fired. Truffle Security scanned millions of websites and found nearly 3,000 Google API keys, deployed exactly as documented, that now authenticate to Gemini. Uploaded files. Cache data, billable inference. Even Google's own hard-coded keys in older Android images work. The architectural sin is not a bug, it is a design choice. One key format for public identification and private authentication. Stripe solved this years ago with publishable keys and secret keys. 2 formats, 2 trust levels. Impossible to confuse. Google chose a single format and then changed what that format means underneath millions of deployed applications. The comments cut to the core. One reader pointed out that Google has never implemented spending limits on cloud accounts despite years of requests. Another noted that you cannot call a key leaked if you spent a decade saying it was never a secret. When you change the rules retroactively, every correct decision made under the old rules becomes a vulnerability. That is not a misconfiguration. That is a breach of contract between a platform and every developer who trusted it. Story 3 might be the wildest one today. Anthropic just quietly rewrote the rules on themselves. A company built its entire brand on one promise. We will stop if we can't prove it's safe. That promise is now a suggestion. Anthropic. The AI lab founded specifically because its creators thought OpenAI wasn't careful enough. Just replaced its responsible scaling policy with something called a frontier safety roadmap. The old policy had a hard commitment. If a model's capabilities outpaced the company's ability to control it, training would pause. Full stop. That clause is gone. In its place, public goals that the company will openly grade its own progress towards. Let's break this down to first principles. A safety policy has exactly one job. It constrains behavior when incentives push the other direction. A policy you can change whenever competitive pressure mounts is not a policy. It's a press release with a shelf life. Anthropic's own explanation is remarkably candid about the reasoning. They hoped other labs would adopt similar guardrails, creating a race to the top. Nobody did. And now, rather than being the only company at the table with self-imposed speed limits, they're removing them. The logic is familiar to anyone who's studied arms races. If responsible actors slow down while reckless actors accelerate, the reckless actors set the trajectory. Therefore, responsible actors should also accelerate. You can see the problem. Once you accept that framing, the word responsible stops meaning anything. The timing is exquisite. The same week, Anthropic is publicly resisting Pentagon pressure to drop AI weapons safeguards. They're quietly loosening the internal commitments that made those external stands credible. The company insists these are unrelated. Maybe, but credibility is not a modular system. You don't get to weaken the foundation and then point to the walls still standing. What makes this genuinely interesting and genuinely worrying is the meta lesson. Anthropic was the test case. If any company was going to prove that voluntary self-regulation could work in AI, it was the one that wrote it into its identity. 2 years. That's how long the experiment lasted before market dynamics won. One commenter put it simply, always the same do no evil tragedy. And they're right, but the tragedy isn't hypocrisy. The tragedy is structural. Corporations are optimization machines. They optimize for survival. When safety conflicts with survival, the outcome is predetermined. The question was never whether Anthropic would blink. It was when. The tools to build safe AI exist. The knowledge is available. What's missing is an architecture where safety doesn't depend on a single company's willingness to leave money on the table. Moving on. What does it actually mean for software agents to learn? Not learn in the marketing sense, where every chatbot claims memory it doesn't have. Learn in the engineering sense, where session 47 is measurably better than session 1 because the system retained what worked, discarded what didn't, and adjusted its approach without a human rewriting the prompt. Agent Swarm is an open-source orchestration layer for AI coding assistants. Claude Code, Codex, Gemini CLI, you point a lead agent at a task. It decomposes the work, delegates to worker agents running in isolated Docker containers, tracks progress through a priority queue with dependencies, and delivers results as pull requests, closed issues, Slack replies. Standard multi-agent fare on the surface. The architecture is where it gets specific. Each worker maintains 2 memory layers. Personal memory, which is that agent's accumulated context about how it works, what it's good at, what failed last time. And shared memory, which is the collective knowledge base the entire swarm draws from. Every session gets debriefed. Learnings are extracted and indexed for future recall. The agents develop persistent identities, expertise profiles, working styles that evolve over completed tasks. This is a real design choice with real trade-offs. Compounding memory means compounding errors if the extraction is bad. It means drift if the recall mechanism isn't selective. The project's advanced context engineering documentation is worth reading on its own, separate from whether you'd ever run a swarm. They're thinking carefully about what to remember and what to forget, which is the actual hard problem in persistent agent systems. One commenter raised the OAuth question. Anthropic's terms around Claude Code tokens and third-party orchestration are genuinely ambiguous. The project uses Claude's own OAuth flow, which puts it in a gray zone that could close at any time. Also worth noting that the architecture is agent agnostic. Swap the coding assistant. Keep the coordination layer. The whole system is MIT licensed. Docker Compose gets you a running swarm in minutes. The lead agent can be Claude Code itself. No container required. Slack, GitHub, email as input channels. SQLite backing store. MCP protocol for the API service. Run this forward. A team of agents that genuinely improves at your specific code base over weeks of operation. Changes the economics of software maintenance. The memory architecture is the bet. If shared learnings compound reliably, You get something that looks less like automation and more like institutional knowledge. The kind that usually walks out the door when someone quits. The blueprints are on GitHub. Go read the memory implementation. That's where the interesting engineering lives. Moving on. Let's make the strongest case against this research. Fentanyl works. It's cheap to synthesize. It's wildly effective at pain management, and it's already deployed globally. Every previous attempt to fix opioids has either produced something weaker, something more addictive, or something that costs 10 times as much and helps fewer people. The comments on this story pointed out directly. Fentanyl saves lives in the global south precisely because it's simple and inexpensive. Why would you mess with the core structure of a molecule that already does its primary job better than almost anything else in pharmacology? Here's the question nobody wants to sit with. Can you separate the medicine from the epidemic? Because what the team at Scripps Research actually did is elegant. They didn't tweak a side chain. They didn't add a molecular speed bump. They ripped out the entire central ring of fentanyl and replaced it with something called a spirocyclic structure. Two four-sided rings joined at a single point like paper chain links. Completely different geometry in three-dimensional space. And the molecule still blocks pain at full efficacy. The craft here deserves real admiration. Bioesteric replacement at the core of a well-characterized drug is bold chemistry. You're preserving the electrical anchor. That positively charged nitrogen that clicks into the receptor's binding pocket, while fundamentally reshaping everything around it. The receptor still recognizes the drug. The drug still activates pain relief, but the downstream signaling changes, specifically zero detectable recruitment of the beta-arrestin pathway. That's the cellular corridor linked to respiratory depression. The mechanism that actually kills people during overdose. In animal models, breathing slowed only at very high doses and recovered within 30 minutes. One commenter noted that every previous fix to synthetic opioids ended up producing something stronger and more dangerous. That history is real and worth respecting. But this approach is structurally different from dose tweaking or formulation changes. This is redesigning the key while keeping it compatible with the law. The real question everyone's avoiding: if you can decouple pain relief from respiratory depression at the molecular level, what's the argument for not pursuing it? Cost? Timeline? The assumption that opioid reform is a policy problem, not a chemistry problem. It might be both. But the chemistry just opened a door that decades of pharmaceutical orthodoxy said was welded shut. The paper is published, the structure is described, the pathway data is public. Other labs can build on this. That's how progress is supposed to work. Put the findings where people can reach them and let the field run. 6 stories in, and we haven't even gotten to Jimi Hendrix yet. Story 6, what a day. The top comment on this one is perfect. I guess that makes Usain Bolt a physicist? And yeah, that's the obvious dismissal. But read the actual article and something more interesting emerges than the title suggests. Rohan Puranik, an edge computing architect by day, decided to do something nobody had bothered to do properly. He took Hendrix's signal chain from the Purple Haze session. The fuzz face, the Octavia, the wah, the Marshall stack, the room itself, and ran full analog circuit simulations on every stage, not digital emulations, not plug-in approximations, actual spice-level models of what each component does to the waveform. And the plots tell a story that guitar players feel in their hands but rarely see on paper. The fuzz face takes a clean sinusoid off the string and clips it into something approaching a square wave. The Octavia, Roger Mayer's custom creation, inverts half the input waveform to double the frequency. An analog octave adds a harmonic content no pickup could generate alone. The Y acts as a sweepable bandpass filter. The UniVibe introduces phase shifts that create movement in the frequency domain. Stack these together, and you've got a modular analog synthesizer controlled not by patch cables and sequencers, but by hands, feet, body position, and a feedback field, and gain staging between components. One commenter points out what makes this genuinely remarkable. Hendrix played guitar for 11 years total, picked it up at 15, gone at 27. In that window, he didn't just master an instrument. He architected a signal processing system that engineers are still reverse engineering 6 decades later. The craft appreciation here matters. Puranik's contribution isn't claiming Hendrix was an engineer. It's that he made the chain inspectable. Every stage can be probed, plotted, reproduced. The mystery dissolves into elegant analog design decisions, and critically, his analysis is published. The models are described. Other people can build on this work. That's the part the Hendrix was an alien narrative actually damages. It replaces reproducible insight with mythology when you can see exactly how the Octavia doubles frequency, when you can trace the envelope reshaping stage by stage. That's more wondrous than magic, not less. The engineering is the art. They were never separate. Moving on. GitHub's a PC returns your email address on every commit you've ever made. That's not a bug. That's how Git works. Your email is baked into the commit metadata. It's part of the cryptographic chain, and GitHub dutifully serves it up through their API. Millions of developers, millions of email addresses, all structured, all searchable, all attached to a detailed behavioral profile of exactly what technologies you use. Now, a YCW26 company called Run Anywhere decided this was a lead generation goldmine. They scraped GitHub activity, identified developers contributing to repos in their space, and fired off personalized cold emails. I found your GitHub and thought you might like what we're building. First name basis. No opt-in. No prior relationship. Just algorithmic intimacy at scale. Let me argue the other side for a moment. Isn't this just networking? Developers put their email on public commits. The API is documented. The data is accessible. If you're building developer tools and you find someone actively working in your problem space, reaching out seems almost reasonable. Except here's where the comedy kicks in. The recipient is in the EU. GDPR applies. Scraping personal data for unsolicited marketing without consent isn't a gray area under European law. It's a violation with real teeth, and the company that did this is in a Y Combinator batch. They presumably had access to mentors, legal guidance, the entire YC network of people who've learned these lessons before. They chose to spam anyway. Martin from GitHub showed up in the comments to confirm this violates their terms of service. GitHub offers email privacy features specifically to prevent this. The infrastructure to do the right thing already exists. The company just didn't use it. What's actually instructive is how the GitHub API creates this problem architecturally. Git requires an email in every commit. GitHub exposes commits through a public API. The privacy toggle exists but isn't default. The system's architecture makes surveillance easier than privacy. You have to actively opt in the protection rather than being protected by default. Every developer marketing person who's been in the industry longer than 6 months knows cold emailing GitHub users is poison. The conversion rate is catastrophic. The reputation damage is permanent. Developer communities have long memories and public forums. This thread is now the top search result for Run Anywhere's brand. The irony is perfect. They scraped GitHub to find their audience, and GitHub's community is now the venue for their public accountability. The system works, just not the way they play in. Moving on. I spent 3 years trying to get a small batch electronics assembly line permitted in the Bay Area. Not a smelter, not a refinery, a clean room with soldering stations. The Air District wanted modeling for lead emissions from solder that we weren't even planning to use. We were going lead-free. Didn't matter, the permit category didn't distinguish. We never built it. That experience is why this project hits different for me. BannedInCalifornia.org maps every industrial process you functionally cannot start new in the state. Not banned by law, exactly. Banned by permit. The Air Quality Management Districts, the Regional Water Boards, the Coastal Commission, CTEA Review. Each one reasonable in isolation. Stacked together, they form a wall that only incumbents can see over. And that's the architectural problem. The grandfathered facilities section is the tell. Semiconductor fabs, refineries, paint shops, they operate under permits issued decades ago. New entrants face a regulatory stack that didn't exist when those permits were granted. The result isn't environmental protection, it's incumbency protection wearing environmental clothing. The existing players get to pollute at levels a new competitor couldn't even apply for. Now the comments raise fair points. The site's creator runs an induction cooktop company, so he's got skin in this game. And some of the banned categories are genuinely misleading. Pineapple farms aren't banned. They're just not economically viable in California's climate. That weakens the argument in places where it doesn't need weakening because the core claim is strong enough on its own. The core claim is this: when you make it functionally impossible to build new industrial capacity, you don't eliminate industry. You offshore it to places with fewer protections. California's air gets cleaner. The planet's doesn't, and the workers in Shenzhen or Gujarat absorb the externalities that Californians decided were unacceptable in their backyard. This is a bootstrapism problem. The latter exists. The regulations are standing on it. If California genuinely wanted clean industry, the permitting process would reward cleaner technology with faster approvals. Instead, the cleanest possible version of a process faces the same bureaucratic wall as the dirtiest. That's not environmentalism. That's a moat. The tools to build cleaner factories exist right now. The engineering is there. The materials science is there. What's missing is a regulatory architecture that distinguishes between a coal plant and a solar panel factory. Until that distinction exists in the permit stack, not just in the statute books, California isn't banning pollution. It's banning production. Different arena entirely. Story 9. How will OpenAI compete? Rock's Law. Arthur Rock, Intel's first chairman, observed in 1998 that the cost of a semiconductor fabrication plant doubles every 4 years. Everyone knows Moore's Law. Almost nobody talks about Rock's Law. And Rock's Law is the one that actually determines who gets to play. Ben Evans just wrote what might be the clearest analysis of OpenAI's competitive position. And he did it by asking a question most people skip past. Not can OpenAI build good models? Obviously, they can. The question is whether building good models gets you anything beyond a very expensive seat at a very expensive table. Follow the money for a second. OpenAI claims $1.4 trillion and 30 gigawatts of future compute commitment. No timeline attached. At the end of 2025, they had 1.9 gigawatts actually running. Sam Altman talks about building a gigawatt of compute every week, which implies roughly $1 trillion in annual capital expenditure. People at TSMC reportedly called him Podcast Bro. Evans more charitably calls it a self-fulfilling prophecy, and notes that Altman's force of will has been surprisingly effective so far. But here's the Rock's Law problem. Even if OpenAI gets its seat, TSMC has a de facto monopoly on cutting-edge chips and captures almost none of the value further up the stack. Nobody builds TSMC apps. Nobody built Intel apps. People built Windows apps because Windows had the users who needed the developers, who needed the users. That's a network effect. Calling a foundation model API is not a network effect. Your customers don't know or care which model you used. The same way nobody using Snap checks whether it runs on AWS or GCP. One commenter points out that ChatGPT's near billion users might constitute real stickiness. His wife uses it daily, doesn't think about alternatives. That's consumer habit, and it's genuinely powerful. But another commenter asks, how long before local models handle 99% of use cases? Both observations point the same direction. The moat isn't the model. The moat, if one exists, is distribution and integration, which is exactly where Google, Apple, and Microsoft have spent decades building advantages that OpenAI is trying to replicate from scratch. Evans frames this as an airliner question. Boeing and Airbus, maybe 3 or 4 foundation model companies survive the capital requirements. But even in that oligopoly, the margins might be commodity level, because some players at the table are using models to power differentiated businesses elsewhere. Google doesn't need its model division to be profitable. It needs search to keep working. The architecture of this market is open at the API layer and closed at the infrastructure layer. That's an unstable configuration. Capital concentrates at the bottom while value disperses at the top. OpenAI is betting everything on the bottom layer being where power accumulates. History suggests otherwise. Last story of the day, and we're shifting gears entirely. 0 hours contracts in the UK just hit a rock tone high. A new hedge was about. The British government commissioned the Donovan Report on trade unions and industrial relations. One of its central findings was that informal, unregulated employment arrangements inevitably concentrate power with employers, because workers without guaranteed hours have no leverage. That was 57 years ago. The UK just hit 1.23 million workers on 0 hours contracts. A raw chord. And the pattern in the data is precise. The surge is concentrated among 16 to 24-year-olds. The people with the least savings, the least negotiating power, the least ability to absorb a week where the phone doesn't ring. Run this forward. A 0 hours contract is an API call. The employer pings the worker. Available, yes or no. No minimum throughput guaranteed. No SLA in the other direction. The worker is on-call infrastructure with no uptime commitment from the platform consuming their labor. The comments on this one cut to the mechanism. One reader traces the path directly. Small businesses needed flexibility to survive lean months. Reasonable enough. Then, larger companies noticed the same instrument could be used to externalize all demand volatility onto the workforce. The tool designed for survival became an optimization strategy. Labor's Employment Rights Bill is scheduled to address this next year. Eligible workers would get the right to guaranteed hours. The word eligible is doing significant load-bearing work in that sentence. The Donovan Commission identified this failure mode in 1968. The corrective legislation arrives in 2026. 58 years of known problem, known solution, deferred implementation. The data kept climbing the entire time. This has been your daily tech feed for Hacker News for February 26, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that outlasts the assumptions it was built on. We'll see you back here tomorrow.